We have the second part. We're still on implicit differentiation. Okay, so the first one, we're going to start with differentiate implicitly. Differentiate implicitly with respect to x. This one. So how do you differentiate that? Don't forget that this one is the same thing as what? As this, the power per half. So the half will go to the front. It's a chain rule. And then minus what? This half minus 1. That's minus half. Then you now open the brackets and differentiate the base. And that will be 4x cubed plus this one will be 2y dy dx equal to, if you differentiate 5x, you have 5, then plus. If you differentiate this one, it's going to give you 3 times 2, that's 6y squared dy dx. So then the next thing is to begin to open the brackets. You can remove this minus here, that will be 1 over 2 square root of what? Of this function. And then times this one equal to this. Can we open the brackets? So this will be equal to this one times this one, 2 here 1, 2 here 2. So I'm having this, then plus this same one times this one, 2 here we cancel. So I'm having y over this dy dx equal to 5 plus 6y squared dy dx. Can we bring the y together? Yes. So I'm going to have y over this, then minus 6y squared dy dx equal to 5 minus this all over this. So that's what we have. Then the next thing for us to do is to make the y dx the subject. It's going to be equal to 5. But before that, we can do the algebra of this one. So this one times this one. So I have this, okay, minus x cubed all over this, okay. So that's that over this one. So I'm going to use a division divided by this one also will be y this one times this one minus 6y squared square root of x4 plus y2 all over this. Okay, so then we can change this division to multiplication. So dy dx is going to be equal to, by the time we do that, this and this we cancel, and that finish the work. Okay, so this one involved a little algebra, and that's what we have done in this case. So that will take us to the second question. So please begin to forward your comments, your contributions. Okay, and don't forget to click on the watermarks on the video and subscribe. Not just that, but also click on the like button and begin to type your comments. Okay, finally share the links of this video on all your social media platforms. Question 2, differentiate implicitly with respect to x. So we're going to have this equal to 0. Then we can move this one to the other side. We have this equal to 2y, the y dx. So you can make the y dx the subject, and that will be equal to this over this, and that's what? X over y. We've gotten the y dx now as this. So we can differentiate further to get the second differential. Oh, they're asking for second differential, and that will be equal to, you can continue from here or continue on here too. So the choice is yours. So you're going to y squared, y, differentiate this one, that's 1 minus x, differentiate your denominator, that's the y dx. Okay, so it's going to give us y minus x times the y dx. We have a value for that, that's x over y. Okay, so over what? Over y squared. The y dx as a value is the value, and that will be equal to this. So if you do the algebra for this one, you're going to have this one times this one, that's y squared minus x squared over y, then divided by what? Y squared, and that will be equal to this over y times 1 over y squared. So that's equal to this. So this one times this one. So that's that. It's just for you to follow the laid down rules for differentiating implicitly, and then a little algebra, and that's all. The next video will be derivative of inverse trigonometric function. So please join the next video on derivative of inverse trig functions. Okay.